Well, this is SQL Query Performance. So we're not going to talk about everything you can do with queries. We're going to talk about sort of the optimization theory, what impacts SQL queries. However, ask any question you want about SQL queries. I do have Management Studio running in another space on my Mac, and we're hooked up to my server on AWS. Can I say that? And so we will go over there. Well, at the end, we will actually run some queries, and we'll talk about bookmark lookups and how indexes affect queries. So if you take your schedule and turn it over on the back, there's a game. And I already found you the two answers that matter the most. So I don't know what you'll win from that, but you know, that's important. Do you all know who Jerry Nixon is? He's the Microsoft guy who helps put all this together. He's the big community champion for us. There's a little bit about me. I live, eat, and breathe, and dream in SQL. I have successfully built a client for a dream when I dreamt the solution. And they said, I don't care how you come up with it, that's what we needed. I like to write, I like to teach, so the SQL Server Bible series was my series until books no longer made any money. So here's the database optimization theory. On the, let's see, that's the left side. There's the database in the middle. There's really basically four components that have to work together to make a database perform well, right? There's all of the maintenance plans and the jobs that run sort of during the downtime. There's the server structure, the infrastructure, the way the patches are done and everything. There's the way the front end calls the database and the database itself. And any one of these could be a weak link and cause a lot of poor performance. Do you all agree? Okay. I was called into one situation where the database was not performing well. They were using Power Builder and Power Objects to talk to SQL Server. I don't know what it does now, but at that time, every individual field control you would drag on a form for Power Objects would do a separate select star where ID is equal to something. And so a form with 42 controls was calling select star 42 times. And the database, they were blaming the database. Of course, that's what they do. So of these four, any of them can cause a slowdown, but I think the real performance gains, the foundation for performance, is in the database itself. And in that situation, inside the database, I think that there's a hierarchy, sort of a leveling of the different layers that support one another. So we'll talk through that really fast, just to sort of lay the context or the stage for how queries set. So the schema, and a lot of times people don't start optimization by talking about the schema, but I know that you've probably seen code like I have, where you see the code and you think, who would write code like this? They're going around their elbow to get to their thumb kind of code, right? And then you look a little bit deeper and you realize that the schema is really bad. And so the way you write your schema can either set you up for success with set-based queries, or it can make it very difficult to write set-based queries. And we'll talk just a little bit about that. And then, of course, set-based queries are going to perform so much better than iterative kind of looping kind of things. So, and then the way you do your set-based queries and the schema sets you up for good indexing. There can be situations where you think you're going to be able to add an index or tweak an index, but it's really not going to make that much difference, or it's going to be difficult to put the index in place. And if these three layers are all working well, anybody from the Midwest, from Wisconsin? So in Wisconsin, we call them bubblers. Everybody else calls them water fountains. So if somebody comes to the bubbler, and the bubbler that everybody's just taking a quick sip and moving on, no line forms. But if everybody comes to the bubbler and they fill up their 32-ounce big gulp glass, there's going to be a line. And that's how concurrency works. The way to solve concurrency problems, yes, you can do some tricks with the way you're handling the locks and those kinds of things, but the real way to solve concurrency problems is to make the transactions really fast and tight. And you do that by these three layers down below. Questions just sort of on this optimization theory and how you approach setting up a database to run well. Okay? So starting at the schema, here's some of my tips for setting up a schema. This is pulled from a 2-day seminar I teach just on smart database design, but these are the big ones. First of all, normalize. Normalization is not something that's going to be evil and cause you a performance problem. In fact, it can save you from having a poorly normalized where you have to write and check multiple places or have code that works around a faulty normalized database. I strongly believe in single column integer primary keys and clustered indexes. And we have another slide coming up on that. But if you have in your schema primary keys that are composite primary keys with 2 columns, then if you have 2 tables, and maybe a natural key or something where it's, you have 2 tables, you come down for an associative or a junction or a many-many type table, and you take the 2 keys, then you make those two foreign keys 1 primary key. I've seen situations where by the time you get all the way down the schema, you're doing joins on 9 columns equals 9 columns. And it's just a mess. And when we talk about indexes on the physical layer, it can cause problems there as well if you have composite wide primary keys.
How do you handle replication when it comes to integer primary keys?
You're going to need to have a GUID, right, for replication. Let it be there and a unique index, but don't make it your clustered index. Okay? Because if it's a clustered index, that's going to be a wider index. And I've got some slides later on to talk about this, but the non-clustered index at the leaf level has the clustered index key at the leaf level and non-clustered. Just makes everything wider. So I don't like GUIDs for primary keys. And that's assuming you're using insert, you're using the new sequential ID method, so you're not doing a lot of the page splits. So there's a thing called a bucket pattern. Yes, question?
On the normalize, I've seen a school of thought that with really massively big data that you don't normalize if you leave it on one table. Have you ever looked into that school of thought? And I'm talking like geospatial data that just takes up tremendous amounts of data.
I've tried most patterns. I've got a slide coming up on this, but I do like having helper tables to sort of denormalize, and we'll talk about that as well. But I still believe in normalization and indexing the foreign keys very well so you still get the good performance.
Okay.
Yep. So a bucket pattern is when you're saying, here's data that's sort of in one status, and then another status, another status. So orders would come in and they'd go in one table if it's a pending order, another for a confirmed order, another table for order being processed, another table for an order complete. And I don't like those kinds of systems because it takes a lot of writes to move data from one to the other. I like rather just putting a status flag or something right on that table. Surrogate nulls. So I don't want to talk too much about this. We can get into a lot of stuff, but I have lost consulting jobs because they based it on, do you allow nulls in your database? And yeah, every database, some place is going to have optional data. Not everybody has a middle name. Not everybody has a termination date or a date of death or something like that. So the optional data does exist, right? The problem with a surrogate null, and a surrogate null is one where you're saying, instead of having a null, we're going to put in an empty string or an n/a. And every time I go to a shop and they say, well, we don't have any nulls in our database, our data is clean. And you start actually looking at the data, they have a number of different surrogate nulls. It's not been very clean and consistent. And when you start looking at dates, they start putting in a date of 1/1/1990, or a government agency might use a surrogate null of July 4th, 1776, or something like that. And then, what do you do with numerics? Do you put in just 0, -99? And then the problem with a surrogate null then is if you're doing any aggregates or sums or something, you need to filter all those out. So now you have to include those on your indexes. It's this complexity breeds complexity kind of solution problem that you get into with surrogate nulls. And the engine is designed very nicely to just have one bit flag to say, this column for this row is a null. And then it handles it properly for the aggregate. So I use nulls where they're appropriate. Where you don't want to use nulls is if you have a number of columns together that either all together as a set include data or don't include data. And there you probably want to break it into a super type, subtype type of pattern. But I want to move quickly through this and get to the query stuff. Two-part names. Always remember and never forget. When I wrote that, it reminded me of the old one day at a time. If anybody is as old as I am, you can remember that used to be a real hot show a long, long time ago. I never create a table with DBA for its schema name. I think that's a huge no-no. I think that you should always have schema names set up by either modules or permission sets. It's very nice then to say this login has permission, this username has permission to every object that's in this schema, whether it's executing stored procedures or executing tables, selecting from table or something. So I really like using schemas and not DBAs. So primary keys. As I mentioned before, single column integer, but I don't like identity. I like sequences better. You probably, how many of you have worked with sequences before? Okay, congratulations. How many of you see identity in your tables? Okay, so if you have identity in your tables, there's a problem with it. Not only is it harder to just sort of like reset that identity and do stuff like that if you want to, you have to do the set identity insert on, and it's a database wide. It's sort of a pain to work with. But here's the problem I see with it is if somebody comes along and they do a join from table A to table S, and every one of the tables has integers for the primary keys and the foreign keys, there's going to be a row 17 in every table. So if you do your joins completely wrong, you're still going to get results that look like they're good results. If you instead use a sequence, and you create the sequence by saying create sequence, you give it a name, here's my schema name, and then as integers start with 1, it caches a whole bunch of them in memory so it can produce them faster than the identity. And then when you insert, you say select, and here's the phrase, next value 4, and you call it from that schema. So you can use the one schema to generate values across all of your data tables. Another one for all of, say, your metadata tables or your reference tables. And that way for all of your data tables, you're not going to, row 17 is only in one table. And then the next table that grabbed one got row 18 over here and 19 over here. So you're not going to have the chance of somebody coming by and doing an improper join. And you're thinking, well, what difference does that make? Well, a lot of programmers think they can write joins, but they really don't know the schema and don't really understand joins. So it's a way of protecting your data. So, questions about the schema layer before we jump into the set-based queries? Any?
Well, it seems like you're limiting yourself to 2 billion rows across all your tables. Which, in some cases, I could see that being an issue. You guys can size your data.
Yeah, you can always make it big end if you want to. Most situations, that's not going to be a problem. Yep. Okay.
Can you comment on the difference between like how you would model your schema for analytic purposes versus how you would model it for storing objects?
Yeah. My hesitation here is that in Grover DB, we have developed an object-oriented graph database inside a SQL Server. So I spent the last several years just researching exactly your question. And we're right now in the middle of filing a patent on it. Okay. So I will say that if you can figure that out, so you have objects with with classes and inheritance, and objects can belong to multiple classes with multiple inheritance, it makes it one of the most flexible and best data schemas I've ever worked with.
I guess, you know, for me, I work in the analytics space. So
Yeah.
we often work with column databases because of the way they store the data on disk.
Right.
That makes them faster to read.
Yeah.
But a lot of other folks are working more with objects that are like users and
Are you talking about, do you want to have row-based indexes or column-based indexes?
well, I guess I'm just saying your approach to the schema might be different based on your business domain or your
Sure.
problem domain. So I was kind of wondering.
Well, one thing that I've experienced and played with is, do you store all your attributes in any entity value pairs or value pairs list, or do you break it out into tables? And I think it really depends upon how the happy path of how you're pulling the data out is how I would design things. I know that there's a lot of folks who will say, I'm a database modeler, I design a perfect logical database, and it's up to the programmers to make it work fast. And I think that if you're designing a database, you need to think about the query path, think about how you're using it, and a good database, like a good book, will be easy to read as well as being factual. Does that philosophically answer it a little bit?
Sure.
Okay, good. It's the kind of question we could spend another hour on. It's a very deep question.
Yeah.
Okay. So the most important thing for query performance is to have a mindset of thinking in sets. And one of the truisms of a programmer moving to be from a front-end programmer to being a database programmer is unlearning all that iterative type of work. And I've seen a number of people try to approach SQL, and they say, well, we can do the simple things in sets, but as soon as it gets complex, we have to break it down and start doing loops. And I have found very, very few things that you really can't do in sets, especially if you start pulling the data and pulling it together in different ways. We're going to have a slide coming up on the tumbling data pattern. And then, of course, it's important to kill cursors. And if cursors becomes we'll take a poll and we'll talk about cursors if that becomes an important thing. But here's the tumbling data pattern. In the tumbling data pattern, usually within one stored procedure, you pull data from some data sources, you put it in a temp table we'll call it temp 1. Then you pull data from here and join it with some more data, and then you do another with temp 2, and you sort of go through this tumbling data pattern of having multiple temporary tables inside of one stored procedure. Do you guys see this pattern at all in some of your code? Okay. This is evil. Don't do this. And it's because people are thinking about, how do I step through and get to my solution? The problem with this is that it includes a lot of extra writes. You're not letting SQL work the way it wants to work. SQL wants to work by saying, it's a declarative language. You declare the problem and then let its query optimizer create a query execution plan that solves that complete problem. What you're doing here is you're saying, no, SQL, I'm not going to trust you to come up with a good query execution plan. I'm going to force you to do one part of it, write it all out to disk, do another part right to disk, and you're breaking it up and you're keeping it from optimizing the way it wants to optimize. So instead of doing, select into temp, select into temp, select into temp, what you could do is break these steps out. So you say, here's the first step. You select what you want, and then you make that a subquery going into the second step. Select what you want, and then put in the last one. And this way you're declaring the entire problem for SQL Server so it can really optimize it the way it wants to. Does that make sense? Okay.
One of the questions that I came in when it was about subqueries and their performance ramifications on SQL engines. Just generally, are there some databases that are better at it than others, or have they all kind of reached a point of maturity now where they can optimize?
I really focus on SQL Server.
Yeah.
The only other database I have experience with is Postgres, and Postgres also has a really nice query optimizer. Years ago, I tried doing stuff with MySQL, and it just crashed. But it's probably much better now. and there's MariaDB, and Aurora looks very interesting to me as well. But you know, the kind of clients I have, you know, tend to have SQL Server. Probably because I wrote the books on SQL Server. There's a chicken and egg problem there, right? But the enterprise likes SQL Server. They feel very comfortable with it, and they know it scales.
On that subject,
Yeah.
I will say that I definitely agree that sub-selects are great. They usually perform really well, unless it's a collated sub-select.
We're talking about that coming up.
Okay.
Yep. But yes.
I didn't want to cut in too much. I think this one's a really interesting question or comment to me, because I oftentimes find myself going down your template data pattern explicitly to control SQL in scenarios where you need a level of control. And one of the examples I keep hitting is a target table, for example, that I got to insert into that I have a lot of contention on. And I need a way to be able to do outside of the lock set of operations to build the table. Writing to tempdb and all of this right into the total waste from there, I'd like to avoid that. Is there any middle ground? I keep hearing table value parameters are worse, but the notion of saying I want this control where I can break an operation into 2 steps but not have log writes.
Well, I wasn't going to get into this, but since you asked the question, so we will. I would say default with the one large complicated query, and then if you find a problem, maybe break one of them out. So in my product, we do have one stored procedure where I broke it out. We do a bunch of work, we store it in a temp table, then we do some more processing on it. But I think that most of the time when you see this, it's not because they're doing it for a performance problem to solve the edge case. They're doing it because this is how they think the problem through. Does that make sense? Table value parameters, I love them. So, yep. So part of thinking about this whole set-based mindset is that there's 3 points of view for thinking about how you're going to approach the query. There's the syntax view, and I will admit I don't really like the syntax of select. I like, it should be, you know, closer to the logical view we'll see in a second. But there's the syntax view of it. There's the logical view on how you should think through how the query works. Then there's the physical view, or the query execution plan. So the logical view of it is, it really, you know, the from happens first. And I wish they had written the syntax that way. But the from is the first part that's going to happen where, and this is not how this is not how it's going to be executed, but logically when you think through it, you first want to think about where am I going to collect all the data from and join it together. And you can think of it in terms of, I'm pulling from these 5 tables and I'm creating one huge, massive denormalized table from all of this. It's not going to happen that way, but that's the logical way of thinking about it. The next thing is the where clause. And the where clause, you then think about which rows am I going to keep and which rows am I going to throw away. After that, you're evaluating the columns and expressions. Then the order by is applied. And finally, the predicate. The predicate is that select top, you know, kind of thing. So this is the logical view of it. And the thing that I love about SQL so much is that here in the data sources, think of all the places you can get the data from. You know, tables, subqueries, CTEs. We'll talk about that from a view. I got to stop and camp on views for a minute. When you're building views, build them in only a single layer. Don't do views on top of views on top of views. And only use views to make it so that your users can get to correctly put together joins and correctly put together selections of data. And just one layer, then reports and maybe ad hoc queries come to it. But you don't want to build your production system on top of views because it'll become a maintenance nightmare. I have been called into situations, you know, come fix this stored procedure, and the stored procedure is, you know, not the simplest query inside of it, but you're going, why is it so bad? Why is it? And then you figure out, one of those tables in there is really a view that's pulling from two other views. It's pulling from two other views, and one view, 3 or 4 layers down, is this massive aggregate view, and all they're really doing is pulling out the listing of maybe different zones or something from that. So views hide performance problems in stored procedures, so I stay away from that. Open queries, table valued UDFs, there's a lot of work here. They're sort of fixing things up and making functions work faster. XQuery, full text search, values. The output is very nice. How many of you have seen the output inside of a query? Maybe I should put a slide on this. Output lets you have a subquery, and the subquery is actually an insert or an update. And then in the middle of that insert update, you say output to this other thing, and you can pass the data from your insert to another query and then go do something else with it, which lets you within one query execution plan insert into 2 tables really fast. Very, very nice. Question?
The other use that I've seen for output is to, when you perform an insert, get the value of the primary key, so that way you don't have to generate a primary key and then insert it. You can generate it on the fly and retrieve it without having to worry about it.
And with like the next value for sequence, usually I'll grab that and put it into a variable. But if I'm doing something where I'm inserting a set, I do the output exactly what you're mentioning. So that's a good comment. Thank you. So simple and correlated. The difference here is a simple subquery. You can highlight it. You can execute it. It stands alone. You're going to get this one value and plug it into, say, every row in an insert. A correlated is the exact opposite. It's something in the outer query where that value is being plugged into the subquery, and you're going to get a different result for every subquery. You would think that that means every subquery has to execute in an iterative fashion, and it's going to really slow it down. That happens very rarely. I've seen really good performance with correlated subqueries. Does that make sense? So this is a really important slide, because if you think about a subquery can return, one row and one column, in which case it's scalar. A subquery can return a list, meaning one column but lots of rows, or it can return an entire table. And so you can use a subquery in every one of these steps, the different logical parts of the query, depending upon how much data it returns. And so this can really sort of open the eyes. You can actually use a subquery right in a column list. Select column A, column B, comma, subquery from something else. And that way you go grab that data and it returns something. And that can be simple or correlated. You can do really wild things with subqueries. And it's some of these techniques that let you think in terms of sets. You grab the data and sort of twist it around and fashion it exactly the way you want to. Questions about this? And on time. So, someone mentioned common table expressions, right? Who works with common table expressions? You see that in your code. Okay. How many of you use them in a general fashion versus using them only for the recursive nature when you're working with a hierarchy? Use them on a regular basis? Sometimes? Okay. Because when CTEs came out, the big flash, the big demos for it was, you can use this to solve your hierarchy problem if you're using an adjacency pairs hierarchy problem. That's where you have employee table, and then one column is reports to, where you store the ID of the manager they report to. So you can say Paul reports to Susan, and Susan's ID is in Paul's row in the managers. That's the adjacency pairs pattern for doing a hierarchy. And you can do a CTE where you say with the CTE name as, and then in your query you have a query that finds the anchor for the adjacency pairs pattern, your hierarchy you get back, then union and the rows that go find the rest of it. So, but that's sort of it always also does something kind of cool thing. CTEs are also just another nice way of building subqueries, and sometimes I'll use them just because this particular query has subqueries that are nested 2 or 3 or 4 levels deep, and there's multiple, so you can sort of reformat that by taking some of the subqueries and making them CTEs, and it might make it easier to read and more maintainable. All right, so it's really an alternate form of a subquery. You can cascade multiple CTEs, and we'll see that in the next slide. When you define a CTE, you can reference that same CTE multiple times in your query. And I used to think, oh, this will be so cool. I can go grab the data once and then use it in multiple places instead of having to replicate my subqueries. It doesn't work. The query execution plan still builds a duplicate path and grabs the data multiple times. Here's one thing that's going to be a gotcha on CTEs, is that you start out, the formatting starts out with the word with. And with is also a way that you put in query hints. So SQL has to have a way of knowing that you're starting a CTE. This is not a query hint or some other kind of hint from a previous statement. So you must use a semicolon before the with. Does that make sense? Okay, so here's a little bit of syntax. So we're saying with CTE1, and this becomes the name of the CTE as, and then you build it out just like a subquery. And so ignoring the CTE2 part, you would say with CTE1 as, here's the subquery, select whatever you want to select, and you can say from CTE, you can join with it, you can do whatever you want to down here. So, and then if you want to have multiple CTEs, you can go ahead and just put a comma and put the second CTE as, and then they cascade so that CTE 3 can reference CTE 1 and 2, 2 can reference 1, that kind of thing. So, but it's the same thing as building it out this way, where you have, here's my innermost subquery, here's an alias, here's the next subquery, and then here's the outer subquery. It's the same thing. It makes the same query execution plan. Questions on CTEs?
So you mentioned that your original thought was, hey, I can query this data once and reuse it. Right. But it doesn't work out that way. So how would you do that?
Well, if it takes a lot of work to get that first CTE or that first subquery, if that's a very expensive operation and you're going to reference it, maybe not 2, but 3 or 4 times, I might test out grabbing that, putting it into a temp table or a table variable, as a way of doing the work only once. A lot of these things you test. Another aspect about testing is that you got to test with the same shape and volume of data you're going to have in production. I have seen so many times that you build it, you test it with a few hundred rows and it's working great, and then you move it to 1,000,000 rows and you have to index differently, and you got to maybe do some of these tricks differently. Yep. It's probably worth mentioning that there's a difference between temp tables and table variables. And it's not whether it's stored in memory or not, it's whether or not it has statistics. So temp tables have statistics, so SQL Server can do a good estimate on how many rows it's going to get back. And that cardinality, or that number of rows it's going to get back when it queries from a table, is how it determines what operations it needs to use in the query execution plan. It used to be, if you're using an older version of SQL, that a table variable, no matter how many rows was in it, was hard-coded to have a cardinality of 1 row coming out of it. So if you put a lot of rows, several thousand rows, or a large number of rows, you'd have a bad query execution plan on a table variable. Now the estimate I think is 100. But still the rule of thumb is, if it's Under a few hundred rows, it's okay to use a table variable. If it's going to potentially be more, you want to use a temp table when you're in your stored procedures. Does that make sense? Any questions? Okay. I have a few slides here just on my personal choice on formatting. I'm not going to spend too much time on it, but it's worth, I think, just basically mentioning a little bit. Because I do a lot of nested subqueries, I mean a lot of them, I've gotten in the habit of saying the outer query, all the keywords are fully uppercase. The next level I do, that's not camel case. What's the name for that, where you just uppercase the first Pascal case? Okay. Who remembers Turbo Pascal from Borland? Oh, those were the days, wasn't it? That was fast.
Yeah.
Okay. And then next time, level 3, I keep everything all lowercase, so I do it something like this. If you actually want to get into not having to play with making SQL Server work hard with correlation differences, you want to do all your data types as lowercase, because in SQL that's what it is. Here's what I do for aliases. If I have an alias for a column, and sometimes you have to do that, I will always put in the as and always uppercase it, because it's too easy to make an error with your commas and have the alias become another column or something like that. So I always am very explicit about that. For my tables in the from clause, I'll always just use the initials of the table. So if it's customer last order date, it would be CLOD, and I would use that as the alias, and I always alias every table with just the abbreviation. And then I use the same abbreviation every time with every query for that table, and I don't use an as in that place. These are just sort of my habits. You're welcome to do whatever you want to. I think with naming conventions, just being consistent is the most important part. Was there a question in the back? No? Okay. You remember was it Big Bang Theory? There was a date that fell apart because they had a big argument over tabs versus spaces. Silicon Valley, that's what it was. Yeah. Man, you can't date somebody who puts in tabs. That's just not going to work. So I set mine pretty short. I try to put semicolons at the end of every statement except for these. If I have to make a to-do note, I'll put in 2 exclamation points to make it easy to find later. The same thing, I always use 2-part names. It used to be a sort of a performance hack to put in DBO dot so that SQL Server wouldn't have to try to figure out which schema does this belong to. I don't think that's a real performance difference anymore, but I like using it for the security of it.
I have heard that it blows the plan cache zone alias tables, because then the entire schema name of the table appears in plan cache.
That could be true. Since I always do it, I haven't seen that problem. but that makes sense. Okay, we're going to get into some indexing. And so clustered indexes and non-clustered indexes. Part of what you need, a mindset you need to take. Well, before we move off of this, are there any other query type questions that you wanted to ask as far as philosophies of how to approach queries and get performance?
I have a question kind of on merge statement performance-wise. I don't know if that...
Sure, don't do it.
Okay, yeah, that's what I mean.
Yeah, here's what I do, and I've had merge statements that I've put in code before, and I've gone back and taken them all out. And I manually write the upsert with the happy path. So if I know I'm going to do an update, I'll do the update, and then if I couldn't do the update, then I do the insert. If I know I'm going to be doing the insert, I do the happy path. So if you manually code those, you'll have more control and have better performance. I do not like the merge command. Yeah?
Just more of a question on format. When you do your inner joins, do you specifically put inner, or do you just leave it as just?
Good question. I just say join. And then I just say left join. And I never, never, ever do a right join. I just so that, you know, I can always read it correctly. I always just, it's either, you know, table, well, let's see. Let me end this show. We can go back and forth still, but now I can slide back over here. So this is my code block, my code script. I start out here with, you know, declaring my standards. I should probably put in there how I do my joins. That's a good comment. If we just come down here and so, you know, here's, it's from indent2 for the join, indent2 for the on. You know, this is real typical for how I write code. Okay, and I haven't found a beautifier to do it the way I like to do it, so it's all manual. Okay, so clustered indexes and non-clustered indexes, and we are right now sort of, because SQL queries don't operate in a vacuum. We talked about the schema supporting the queries. Now we're talking about the indexes. You can sort of almost think about an index as a real high-performance bridge between the query and the table. How am I going to get to the answer faster? So we got to talk about clustered indexes and non-clustered indexes. And I like to think of it in terms of, once you get at this level of thinking about it, there is no such thing as a table anymore. Tables are gone. Tables just an abstract term you use to describe sets of indexes. SQL Server at the physical layer only works with indexes. So don't even think about terms of tables anymore. There's a lot you can get into. One of the longer chapters in my book is the chapter on indexing. We're just going to look at a couple of the examples here that really lay out the biggest problems for it. And I think once we establish this was a cluster, what's a non-cluster index, and we get into the problem, we'll start seeing, yeah, this is really where the meat of the problem is for most indexing situations. So a clustered index looks like this, where there's a B tree or a balanced tree, where it just basically just says, you know, that A through N go here, you know, O through Z or Z go here, and it just sort of like splits it out, and then it goes to the page, and then it finds it on the page in the data columns. So a clustered index then has all the data columns and the balanced tree of whatever your clustered column is. This is the sort of what it looks like. So you don't want to have this tree portion really bloated out with a lot of extra data, with composite primary keys or GUIDs, or, you know, let's index by everything that makes this unique, which is maybe the employee name and their hire date. So we're not going to allow us to hire two people with the same name on the same date, and that makes them unique. You know, maybe it sounds logical, but it's going to be a performance problem. So questions about a clustered index. It's the same thing as the way you would think of a telephone book. Questions? Okay. And then non-clustered indexes. And I have to click on it here. These you can think of as in the back of the book, but you can have multiple indexes in the back of the book. So let's say you have a history book, and the clustered index is by the chapter, but then the non-clustered index is a listing of all the people and what page number they're found on. So you can do a lot of, you can get your work done a lot faster doing your homework if you can go to the back of the book, find Jefferson, and then find the 15 places where he's referenced. So that's a non-clustered index. And if you think about how it would have to work physically, it has to have the way to find the data on the clustered index, right? So we end up doing this kind of work. It's called a bookmark lookup. So if we want to find me every page that talks about Jefferson, we're going to go to the back of the book, the non-clustered index. We're going to go, where's the J? Where's the J? Here's the Jefferson. And then we're going to say, well, here's the 15 times it's listed, and here it's listed on this page. I only show one here, but here it's listed on another page, and here's it's listed on this page. So if you think about this, and granted, the binary tree here might have more few, but in this example, if we wanted to find where Jefferson is listed, and let's say it's listed in 15 different times and scattered throughout, we'd be reading 1, 2, 3, 4, 5, 6, 7, 8, 9 pages just to find all the references about Jefferson, because we have to do this bookmark lookup from the back of the book non-clustered index to get to the clustered index. Does this make sense? So if you have a non-clustered index on your customer table and you have 2 million customers and you're trying to find everybody whose state is New York, and that's throughout the whole thing, you might be reading, even though you have that non-clustered index there, you think this is going to be fast, your performance will still be slow because you're going to read from one index, you're going to find out the, New York comes up with 1,000 links over to here, then 1,000 times it jumps over to the clustered index and finds the data. And if you actually open up the query execution plan and look at the properties of this, you'll see that this is being called 1,000 times if there's 1,000 people in New York. So people don't, and it used to be that when you looked at your query execution plan, you would see one operation that said bookmark lookup. You wonder, why is that taking so much work? So let's go ahead and jump in and actually see one. We'll come back over to here. So I am logged into AdventureWorks 2017. We're looking at the production.work order table because it's one of the larger tables, so we can actually get some work being done. We're going to look for product ID equals 757. Okay, we were going to do the 737 max, but it crashed. That was a really bad joke, I'm sorry. I didn't plan that very well. So we end up with 9 rows coming back, but if you look at the query execution plan, it looks like we've got an inner join between a non-clustered and then a key lookup. And we're looking at this and going, well, this makes no sense. How come SQL Server is doing an inner join when we're only looking at one table? It doesn't make any sense at all. But what it's trying to do is let you physically see that we're going to find data from one index and then join it from another index. So if we look at this, let's see. This was, here's the non-clustered index where it goes and grabs the data first. Number of executions is 1, right? And so even though we read it from left to right, it's actually being, the data's being pulled right from left. So it's being, I said that backwards. We normally think about the flow this way, but actually select calls the nested loop. The nested loop calls this once, then the nested loop is going to call down here. So let's go and see, look at the key lookup. That's the operation of going and getting the data from the clustered index. Notice here it says I don't know if you can see this very well. It says non-clustered, then it says clustered. Let's see, what is the keystrokes for making it zoom in? Oh, that was big. Maybe a little less. A little more? Okay, then if we highlight down to this one, and if you see number of executions is 9. And so that bookmark lookup is what's really going to eat up your performance. Does that make sense? Okay, so let's turn off the magnifier here. And the solution for that is to do what's called a covering index. And a covering index, there's no checkbox or something you can say, make this index a magical covering index. It really means this index by itself can cover the needs of the query. And it used to be that you had to do that by inserting all of like, you know, if this is work order on product ID and we only have product ID right here in the B tree, we would have to add product ID, comma, start date to include start date in the B tree to get to be able to answer all of the question of the query right in here. But in 2008, or was it 2000? I think 2008, still a long time ago, they added the ability to insert extra columns right in the leaf level. So in the leaf level of this non-clustered index, it now has the product ID, because that's the clustered index. It needs to point over the clustered index, and also includes the start date. So whenever you make any changes here to, you know, whether it's an insert, update, or something, it'll take that start date and duplicate it over into this index. So now when we go ahead and we want to say select product ID or work order ID and start date from the work order table where product ID is 757, it can find the 757 rows using the B tree, and then it can find both the work order ID, because that's the clustered index, and start date, because we included it in this index. It's just extra data being duplicated so that this query alone can solve the problem without jumping over here 9 times. So covering indexes are really, really good. Questions so far? Yeah.
So the create statement for that index on the left would have just been create non-clustered, and then it still has the product ID and then comma.
Yeah, we're doing it right here. So, so this is, let's see.
Oh, so it has include.
Yep. Yeah, so drop it, and then we're going to create the same index on, let's see, let me move this down here and make it a little bit easier. On the table, using this as the key for the index, and then we'll also include start date. So go ahead and execute that. And then we'll slide back up here, execute the same query. Oh, and it really, I should have come over here and looked at the overall cost, but now you can see it's just one index seek. So it's really fast. In some places, you know, it really depends. For speed, you're looking at how many data pages did we have to load and process, or even if they're in memory, how many data pages did we have to hit for this query to be executed. So you can see that with the bookmark lookup, you potentially could have gone from hitting thousands of pages down to hitting 2 or 3 pages. And this is the biggest performance gain you're going to get from indexing and having, working with your queries. There's other important things to know too, as far as making sure that the queries are sargable, meaning it's a search argument, that you don't put functions around parameters in your where clause or some other things. But this is sort of the biggest thing that you need to understand. Questions about bookmark lookups and covering indexes? How often do you think you should use bookmark lookups?
As little as possible.
Okay, and there's a strategy though here too. And I want to go ahead and talk a little bit about that strategy. You know, the Pareto rule, the 80-20 rule, or the 95-5 rule, something like that, which is what I see. So a number of times when I'm called into a query, a database optimization problem, what I'll want to do is I'll run Profiler, I'll capture all the stored procedures, all the queries, pull all that data into a table, do an aggregate, a group by, sum up all of the CPU time it's taking, and then I'll be able to say, well, this is how it's looking as far as which queries are taking up how much CPU. I know it's sort of a simplistic way of looking at it, but that's what I like. I like looking at sort of what's the big picture here. Almost always, what the client says is, this stored procedure or this query is causing my problem. That's not even in the top 20. Usually the problem is those other queries that they think they've done well, but they haven't done well. that are just being executed so much, so often, so frequently that that's eating up the bulk of the CPU. It's even to the point where it usually boils down to a handful of queries, 5 to 7 queries or stored procedures that's eating up 95% of the CPU. It's that dramatic for most applications. For my application, it's the get object ID, browse objects. That eats up almost all of our work. So what I like to do is say, for those that are eating up all the CPU, do whatever you can to make sure you don't have a bookmark lookup. Apply the covering indexes. For those others, though, don't run so frequently, I say it's okay to have bookmark lookups, because you don't want to build too many covering indexes, because you'll end up with non-clustered indexes. Here we had just one column added, but typically you'll add multiple columns, and then you're bloating out your non-clustered indexes, and you're doing a lot of extra writes when you do an update. You're not only updating it if it's the binary key that's being changed, but all those other include columns being changed as well. So there's a cost to doing covering indexes, but there's a real gain as well, as long as you don't overuse them. So, questions so far? How are we on time?
Is there a reason you do it using Profiler instead of running a query against one of the system databases to pull CPU usage time? I'm
old school.
Okay.
I grew up on Profiler. It's my friend. It's like the fun. It's like a puppy to me. I'm always there.
I use Profiler all the time too.
I mean, everybody keeps telling me you should be using X event. It's like, well, Profiler does exactly what I need with 3 clicks. Why would I learn? I love Profiler.
I use Profiler all the time too. But yeah, no, I've done the same thing, but just running a query to pull CPU usage time out of the system, and then creating an index based then going and running the queries and stuff based on that.
So we've gotten to this final slide. This is my Q&A slide. They're Qing, eh? I love this slide. I like dad jokes. Yeah. If my daughter says, no, Dad, don't do that, I've got to. But seriously, any final questions, anything at all? Okay, there is my email. If you get stuck on a query or a query execution plan, email it to me. I've had that as an open offer to people who read my books. Every once in a while I get emails, that kind of stuff, and I try to help out if I can. Don't send long chapter length stuff. Just say, how do I solve this one problem I'm stuck, kind of thing. If you want to connect on LinkedIn, I'm not begging you to or anything like that, but I have a very large LinkedIn sort of set of connections all in the database world, so if it can help you be found to get work or something like that, go ahead and connect. I approve all connections. If there's any way I can help you, just let me know. So our time is, we have 2 minutes left for a final question. Yes, Doug.
What is your, where's this YouTube? The video?
I'm going to post it up. I'm going to name it the name of this session. But if you look for my company name is GroverDB, so we have a few videos up there about our product. So I'll probably post it in that same channel, but I will name it this, and it'll be up there this weekend.
So just do a search for GroverDB.
Yeah, or SQL Query Performance. And it usually takes, even when we post YouTubes, I have found it takes a little while before the YouTube search engine finds them. Yep.
For, I guess, tables that you're actively loading lots of data into on a regular basis, do you think it's good practice to drop and recreate indexes if you have a lot of them to improve the user performance, or just leave them as is and let
it's worth testing. I've seen places where dropping, recreating indexes helps in that data load. Sometimes recreating the indexes is so laborious. It's just something you got to test with your data load. But
I guess a follow-up question with that: would a column store index generally? I mean, if you're weighing the, I guess it's something you just have to test, but multiple non-clustered indexes versus kind of a clustered column store index. I guess, is it generally better to just have the clustered column store index have take care of a lot of the query plans? I don't know if that's a general rule, or it's probably hard to.
yeah, we didn't get into the whole indexing session that I would normally give, but you would want to index or build non-clustered indexes for foreign keys, for where clauses. You start out with a base set of non-clustered indexes until you prove that they're not being used, is how I approach it.
Okay.
And almost all of my work is OLTP, operational and transactional databases. I don't do a whole lot of data warehouse type work. So the typical thing that I work on are airline reservation systems.
Like super fast, like one.
Right. Yeah. Yeah. One of the most challenging, one of the funnest things I've done was how to do manual upserts to keep everything fast enough in airline reservation systems. That was really good. There's one large state in the U.S. whose tax database is not keeping up, and I get to go there in 2 weeks and try to optimize it. But I hope I have to know nothing about the domain. Yeah. Yeah. Yes.
Do you have any kind of rules of thumb or tips on improving the performance of groups and aggregates?
Yeah, index on the aggregate. Yep. Another sort of tip is be very careful with your data types. If you start messing with your data types, it causes lots of little data conversions in there, and that can throw off a query execution plan. This was intermediate. What are the big high-level concepts you've got to know to get your head wrapped around query optimization? And then you can go way, way deep on this stuff. The last tip I'll give is Pluralsight. Some of the courses on Pluralsight by Kimberly Tripp, they're very deep, but once you master all of this, that's where I would go next. Another great resource is the SQL Server Internals books by Kaylin Delaney. Kaylin is an awesome instructor trainer. If you get a chance to see anything by her, I would recommend it. Okay, we are out of time. I want to be respectful for the next speaker to set up. So I thank you all very much. Have a great weekend.